Alright guys, welcome to RC Mojo. We're going to do a bit more to the Hercules Hobbies Actros this week. We're going to put together the 3-speed gearbox. If you've ever put together one of the Tamiya 3-speeds, it'll be immediately familiar, which is a good thing as the Tamiya gearbox is extremely reliable as long as you put it together carefully. Unlike a lot of other multi-speed gearboxes, the Tamiyas always shift very nicely and positively lock into the gears. There's loads of bits and bobs for this section of the build. Gearboxes with a bit more going on have to be one of the most interesting things to put together, especially with these 3 speeds, as you can run up the gearbox with the covers off and see it all working away. Right then, step 18, shift rod and 1/2 of the frame. First, for the big bits, we need the end plate with the motor mounting and the 3 aluminium tubes, the shift rod, the 3 shift forks, the short rod with the thread at one end, 2 small E-clips, 2 M3 flange nuts, 2 M2 nuts, 2 M2x6 screws and 3 M3x6 screws. We need a couple of plastic bits too. There's J2, a bearing carrier, and J1, a small spacer. We're going to start off with the shift rod. We need to make sure that the shift forks are going to run freely on the rod before we do anything. They should slide and spin freely on the rod, but at the same time they shouldn't be too loose that they wobble. If they're tight, you might be able to get away with passing a drill through them. If they're loose though, you'd probably be looking for a set of Tamiya ones. It looks like they've got these right though, as they do feel pretty good. It would be an easy thing to get wrong if the tolerances are off just a bit, and they would ruin the reliability of the gearbox. To start the actual assembly, we need to line the rod up with the diagram. The rod has lots of slots in it for E-clips, but it's not symmetrical. If you start building with it the wrong way round, it would be a bit of a pain having to take all the clips off again. In the middlemost 2 slots that are close together, we need to fit a pair of E-clips. The slots are fairly generous, so the clips go in quite easily. But if you're worried about pinging them off, stick your hands in a clear plastic bag. That way, if you do lose one, it's not going to go far. Now we can fit the shift forks. They're going to see quite a bit of sliding up and down the rod, so we need to make sure that there's some grease in there. Smear some on the rod, then spin the fork on to try and spread it around a bit. Same goes with the other 2 and the spacer. Even if they don't actually slide on the rod, but rather move with it, things will twist and turn a bit, so generally anything in the gearbox, if it moves or you think it might move, just add some grease. Any excess will quickly get squeezed out once it's all up and running. To fit the bearing carrier, we need to drop the 2 small nuts into the hex holes on the carrier. They're not a tight fit, so don't let them drop out. Then we can offer up the carrier to the inside face of the end plate. To work out which face is which, the little bushing insert for the shift rod is flush on the inside and it sticks out on the outside. To attach the carrier, all we do then is install 2 M2 screws and nip them up. Next we've got the short rod with the thread at one end, and unfortunately it looks like I missed the record button, so all we get to see is the final tightening. The rod is there for a widget to run on that keeps the shift rod from turning too much. It's really not all that critical how it's installed. As long as most of the thread is covered by the 2 flange nuts, it'll work just fine. That leaves the aluminium tubes. We're only installing 3 of them at this stage, so we've still got access to install the other bits later. They're attached with the M3 screws, and for now we'll just do them up finger tight. Once the gearbox is running, we'll pop them out again and add some thread lock. Step 19, gear shaft A. We will of course need gear shaft A, easily distinguishable from gear shaft B because there's an almost real size diagram to match it up to. We need a couple of gears, the 20 and 13 tooth, the gear hub short, it's just a spline to hex adapter, and we'll need 6 large E-clips. When we've got to it, we'll also need the 36 and a 27 tooth plastic gears. Now if you've built a Tamiya gearbox, you might notice that the metal gears are brass rather than aluminium. If we look at a clip from the Grand Hauler build, you can see the Tamiya gears. They work just fine, but if you take apart a 3-speed that's seen some use, you'll see the grease around the aluminium gears has turned grey. That's material that used to be part of the gears that's worn away. It's not a huge deal, as it will still take many years for the wear to become a problem. Hercules though has chosen brass, which is much harder and should wear better. I should think it will more or less last forever as long as the meshes are good. Just like the shift rod, we need to make sure the shaft is the right way around by matching it with the diagram. We need the two short splines on the left for the first bit of the assembly. First job is to install the two E-clips either side of the long smooth section. Again, the slots are quite generous, so the clips go in very easily. Before we slide on the brass gears, we need to apply a little bit of grease over the splines. There's going to be a little bit of slop in there, so the gears will naturally rub ever so slightly on the splines. The grease will just help a little bit in making everything last longer. On the first small spline we want the 20-tooth gear, and over the long spline we want the 13-tooth. And over the 13-tooth we need to slide the plastic 36-tooth gear. A little bit of extra grease wouldn't hurt while you're there too. To keep the big gear in place, we pop an E-clip on the end of the shaft into the second bit of the diagram, and we clip an E-clip in that stops the 20-tooth gear from falling off right away. Something that's quite easy to miss on a quick glance, the second part of this section has you flip the shaft over, left to right. There can be a bit of confusion if you don't notice. The next slot along the shaft needs an E-clip, then the short gear hub with the 27-tooth gear, and don't forget to add a bit of grease as you put it all together. The last bit to go on is yet another E-clip on the end to hold it all in position. Well, that went together rather well, just as well as a Tamiya, and with the bonus of brass gears rather than aluminium. 10 points to Hercules. Step 20, gear shaft B. This one's a bit more complicated as we've got all the clutches to worry about. Okay, we're going to need the shaft, a fairly large thick washer, 4 1260 bearings, 4 1150 bearings, 2 long gear hubs, and 6 large E-clips. For the plastic bits we need all 3 of the dog clutches. Now each one is unique, so keep track of which is which. And when you remove them from the sprue, make sure you smooth out any nubs and moulding flash so everything operates super smoothly. And that just leaves the J5 spacer. Right, the first thing they want us to do is pop a couple of the 1260 bearings into the J7 clutch. They want us to use some glue to stick them in, but as long as they're a nice snug fit, they're not going to go anywhere. It's actually debatable whether bearings are a good idea at all. A lot of builders use the bushings as they won't be seeing a lot of rotation, but they do slide up and down the shaft. There's regular discussions on forums with all the pros and cons. Now I usually use bearings when they're available, and with a good generous coat of grease they do the job just fine. Next then, we install an E-clip in the centre slot of the shaft and grease up either side of it. On one side we slide on the J7 with its bearings, and on the other we fit the 37-tooth plastic gear with a 1260 installed on each side. We are going to be greasing up the clutches too, but for now I'm just going to leave them dry so it's easy to handle the gears without getting covered. And now just behind the J7 clutch we need to clip in another E-clip to stop it falling off. Much like the last section, we need to flip the shaft over to match the diagram and fit an E-clip behind the plastic gear to hold it on. Grease up the splines next to the clip and slide on one of the gear hubs, followed by yet another E-clip. On the clutch side we can slide on the large washer and grease up the splines ready for another gear hub. We're going to have one of the clutches sliding up and down on the hub, so we need to grease up all the faces before we slide on J8. J8 gets followed by an 1150 bearing, the 44-tooth gear, another 1150 bearing, the J5 spacer, and finally an E-clip. Going back to the other end, we need to grease up the gear hub, slide on the J6 clutch, then a 1150 bearing, the 30-tooth gear, another 1150 bearing, and lastly an E-clip. Now we just double check everything's in the right place and right way round. It's very easy to miss something, so we need to really check carefully. If it's all okay, we can go in with the grease and pop blobs all around the slots that the clutches lock into. A bit of a blob either side will do, and once the gearbox is up and running, it's going to find its way round and the excess is going to get squeezed out and flung off quite quickly. Step 21, putting it all together. This bit's always fun. We need all the bits we've assembled so far. 4 1150 bearings, 2 3mm washers, the 2 shift springs, 5 M3x6 screws, the remaining aluminium tube, and the other end plate. For plastics, we've got 3 J3s, cups for mounting the bearings. First, on the plate that we already fitted a bearing to, we need to pop in one of the cups in the lower hole and press in a bearing. Then in the top bearing we fit shaft A, the first one we assembled, and in the bottom hole we want shaft B. Pop a bearing on a cap on the end of the 2 shafts and check all the gears are nicely aligned. If not, you probably got something wrong during the build, but now's the time to make sure and go back and fix it. If it does all sit nicely, we need to fit the springs and washers to each end of the shift rod. Then carefully slide out shaft B and slot the 3 shift forks into the clutches and refit. It's a bit tricky as you need to guide it around shaft A while getting the shift rod in through its little bearing. Next we can fit the second end plate and the last aluminium tube. All the screws just need to be finger tight, plus a little bit for now, just enough to keep it all together for a test. We'll end up taking out all the screws for some thread lock if it all works as it should. If the gearbox passes one final visual inspection, don't worry if it's a bit stiff and notchy right now, we can go ahead and grease up all the things. Get a nice coating over all the gears and add some where the shift rod passes through the end plates. If you turn it now, after a couple of rotations it should start to smooth out. If you turn it now, after a couple of rotations it should start to smooth out, and with a bit of force the gears should shift by moving the rod in and out. Step 22, the motor. We need a few small bits for this one, as there's a bit more to it than just fitting the motor. We're going to need the brass pinion, not aluminium, very nice, the drive cup, the shift arm, which is just a collet with a small metal plate attached, a 4mm ball end, 2 M3x6 screws, an M3x4 grub screw and an M3x3 grub screw, a 3mm washer and 2 small E-clips. For plastic parts, all we need is a J4 spacer. And of course we can't forget that we're going to need the motor. Now we're probably going to end up replacing this one for one that we know the number of turns of. 55 turns is probably going to be a good place to start, but we might end up even higher. But the stock one will get us going. The 2 E-clips go on each end of the shift rod. They're there to limit the travel. They just clip into the slots. Now I did run into a little problem with one of these. One of them snapped when I was clipping it in. Most likely the metal was just a little bit too hard and it couldn't open up far enough. Not a huge issue, as 2mm E-clips are easily available. And of course if you do lots of RC building you've probably got some already. Next we'll fit the drive cup. On the end of the output shaft we need to slide on the J4 spacer before the cup goes on. Next we can apply some thread lock to the M3x4 grub and thread it a few turns into the cup. Slide it onto the shaft and with the grub in line with the flat, tighten it up and then give it an extra little tweak. Once the thread lock hardens, it's really not going to go anywhere. Next we've got the shift arm, and just like the cup we'll use a bit of thread lock on the screw. This time it's the end of the 4mm ball end. The brass bit goes up against the E-clip and the hole in the steel plate runs up and down the small rod to keep it straight. Nip up the ball end and it's ready to go. On the motor we need to fit the pinion. You could use some thread lock on the grub screw, but it'll hold well enough without until we swap the motor. So we'll just fit it to the motor and tighten up the grub just enough it's not going to fall off. Now you can fit the 2 motor screws. The one that goes through the single hole just uses the screw. The adjustable side also has a washer. We just need them tight enough that the motor's stiff to adjust so we can still move it. The first adjustment we need to make is the pinion position on the motor shaft. The teeth of the pinion should sit centrally on the plastic gear. Loosen the grub and set the position. When it's spot on, tighten the grub screw and give it an extra little tweak just to make sure. Next is the gear mesh. Now we've got very large pitch gears, so nowhere near as critical as with other kits, but it still pays to get it right. The quick and dirty method uses some paper between the gears to make sure you get some clearance. It works, but I usually find it ends up a bit on the loose side. It's a safe way to go though, if you're not sure. When you're sure you've got a good mesh, nip up the motor screws so the motor can't move. Now, since you've got a nice open frame gearbox, it would be a shame not to test it while we can see all the insides. I'm using a bench supply, so at low voltages the motor isn't going to have a vast amount of torque, but it should get things spinning. With it hooked up, it's a little bit reluctant to run, but that's quite normal on a current limited supply. It will be lowering the voltage to keep the current down. With a bit of help on the output shaft, we can get it spinning though. And after a bit of running, it does all start to free up quite nicely. And most importantly, it's changing gears with very little fuss. Just remember, if you try bench running a gearbox like this, you can get quite a nasty nip if you get your fingers in the gears. You only ever do that once. The other thing, now it's been spun up, you can see how a lot of the excess grease has been flung off the gears. You can see the build-up on the aluminium tubes very clearly. Step 23, putting the gear case on. Now this one's pretty easy. We'll need the 2 gear case halves, 5 M3x8s and 5 M3 nuts. All we do is pop the case halves over the gearbox, then on one side we fit the nuts into the hex-shaped holes, and on the other side we fit the screws. Do that 5 times and we've got a complete gearbox ready to fit. Step 24, the shift rod assembly, that I think I'd call a gear shift linkage, I think. Another super quick one, we need the 2 small plastic rod ends and the small cranked linkage. This time we just need to screw the linkage into the rod ends, so we end up with a linkage that matches the dimensions on the diagram. Remember though, the diagram isn't quite actual size, so you'll need a measuring device of some sort to get it spot on. Step 25, fitting the gearbox. We're going to need the gearbox of course, prop shaft and shift linkage, 4 M3x8s and the chassis. All we need to do is slot the gearbox in between the chassis rails. You do have to kind of tilt it in, but there's a nice diagram on the left of the page that explains it, so it's really no trouble. Slide the gearbox all the way to the front and offer up the prop shaft, slotting it into the axle's drive cup. Then slide the gearbox back and fit the prop shaft into its drive cup. Then all we do is fit the 4 screws through the mounting lugs into the chassis. At least we would if the screws fitted through the lugs. The slots are way too narrow for the screws. So the gearbox comes out again and we can attack the lugs with a round microfile just to open up the gap. It only takes a couple of strokes. Now we can refit it all again. This time I'm also using some washers under the screw heads just to spread the load a little. You probably get away without them, but they will help. That just leaves the shift linkage for today. One end just pops onto the ball on the shift rod, and at the other end the ball on the shift servo. Now we might end up needing to adjust its length a bit to get the shift servo working spot on, but it's going to do the trick for now. So that's one 3-speed gearbox built and mounted. We won't know until the truck's fully up and running, but I think it's a perfectly good gearbox. One of the more complex assemblies in the kit, and it looks like they got it right. Great stuff. So that's it for this week then. Quite a nice bit of progress. I do like it when you can work through a complete assembly without any leftovers. It actually feels like you finished something. Anyway, as always, thanks for watching, like if you liked, subscribe if you're not already, and do please leave a comment. I do read them as the email notifications come in, but I've got a bit of a backlog to reply to now, so sorry if I've left you hanging. Bye guys!